All right, fundamental theorem of calculus. This is based on what we've already done, the definite integral. So I'm going to show you a definite integral, and then we're going to build the fundamental theorem of calculus from that. Okay.
Is that 7?
Yes. I can write it however I please.
Okay.
No, I don't always just copy out of the book. All right, there's the integral, correct? The power rule. And then plug in. Yeah, don't put the big parentheses there, put small ones.
Oh.
All right, so we got this far, right? You guys are money here?
Yeah.
The definite integral. Okay, so here's how we define things. Okay, if x squared is f of x, big F is an antiderivative of little f, okay, the integral. We can say that that's true. Does that make sense? So, okay, if you look at the example here, that's big F of x, correct? All we've done is evaluated f from 7 to 2. So big F of 7 minus big F of 2.
Oh.
Okay, so it's a very clean and neat way to write it. And it defines the interactions and the relationships between derivatives and antiderivatives. It defines what an integral is. Okay, so part 1, here it is formally. Okay, it has to be continuous. If big F of x is an antiderivative of f on AB, then we have this definition. Very important that you know that it's continuous. With these big theorems like the mean value theorem, the average value theorem, fundamental theorem of calculus, intermediate value theorem, AP testers like to ask, is this, can you apply the fundamental theorem of calculus to this problem? Okay, if it's not continuous, you say no, basically, right? But if it is continuous, you can apply it. So be careful there.
If it is continuous within the given area.
Yeah, in the interval. All right. So why do we use this? Now, you're basically, all you're doing is a definite integral. Okay, that's all this is telling you. It just defines what it is. Okay, here's an example. And this is a different wording. All right, what function do you want? 2?
2x plus 2.
And what interval?
2 and 4. Okay.
We are getting
Nowhere.
out there. Okay, so is this continuous on this interval? Yeah, it's linear, so it is continuous. Okay, continuous. Okay, check. So we can use the fundamental theorem of calculus. I'm going to write it like they write it. Yeah, I know you can solve it. We need to see the practice. So this might be an answer on the AP test. They say calculate the area under the graph of blank over blank. That might be the answer, right? So very careful there. The integral of this is x squared plus 2x, right? Hopefully my math is correct. Hey, do you want me to show you another one? Or are you good?
Yes.
More complicated?
Yes.
Like a circle. Yeah. Explain the
We're not that far advanced in our integrals yet, so. Yeah, you'll learn substitution and numeric integration. Okay, find the area under the graph of g of x equal to x to the negative 3/4 plus 3x to the 5/3 over 1/3. Okay, where is that have a discontinuity? What is this? Okay, so this tells us that there is a discontinuity at 0, right? But it's not in our interval, so we're okay. So it is continuous. Now, what's the yeah, just finish her up. Take the integral.
Wait, I'm just saying. Equals
It would be G.
large G.
You could say that, yes.
Okay. What did you do there between those two steps?
I took the integral and simplified it. Okay, so if I add 1 here, that's 1/4, right? And then divide by 1/4 is the same thing as multiplying by 4. Here, adding 1 is adding 3/3, right? 3/3, so that's 8/3. And then on the bottom, it would be 3/8.
Okay.
Or sorry, it'd be 8/3 here, which flips to 3/8. So 3 times 3/8 is 9/8.
Okay.
So I did that all at once. And then you basically get to do some really fun math. Basically plug it into your calculator, get a decimal. This one's straight out of your book, so. Thanks for that. You make me laugh.
Approximately.
Yeah, it's approximately 21.2.
What is the scribble? No, the scribble on the explanation.
That's 8/3. That's me writing in pen is what that is. Okay, I'm going to stop there. Tomorrow I'll show you a few more. Not a big deal. You've done all these. We're just going to keep hammering the basic integrals. So the fundamental theorem of calculus 2 is where it gets more real.
All I showed you today was those. If you want to just do those and do your AP problems, you can. Yeah, do the rest tomorrow.